So thank you very much for joining today's webinar, Unlocking Historical R&D Knowledge to Discover Untapped Scientific Value. Today, we're very lucky. We're going to be joined by Geraint Duck from Syngenta and Balvinder Dang from DataVid. Geraint is going to walk through their Synapse application and what that has meant to their business and the value that it's driven throughout their business. And then Balvinder will give us a quick summary of that. And then we're going to go on to Q&A at the end. So if you've got any questions, please do let us know. And so without further ado, I'm going to hand over to Geraint. Geraint, it's over to you.
Thank you very much. So yes, so as Philip said, I'm Geraint Duck. I'm based at Syngenta, so I'm based in Gellets Hill in the UK. I will tell you a little bit about Syngenta for those of you that aren't familiar with the company. I'll then give you a bit of discussion around our document search tool and solution, and then we'll finish with a bit of what the future holds at the end. So, title of my talk, so Unlocking Historical Knowledge to Discover Untapped Scientific Value, and in particular supporting innovation. So we are an R&D company, so innovation is very important to us through semantic document search. So Syngenta. Syngenta is a leading science-based agricultural technology company. So in particular, we help millions of farmers globally around the world to grow safe and nutritious food while taking care of the planet. So our mission is to help feed the worldwide population in a way that is as sustainable as possible. So to expand on that, so I mentioned sustainability. So we protect plants through sustainable innovation. So I'm based in product safety in the UK. I'm a part of our crop protection business. And I said innovation is very important to us. New products that we need to get onto the market to help our farmers grow more crops given the same amount or less land than they used to have. So increasing that efficiency. We're also a seeds company, so we also develop and provide and sell seeds. And as you might imagine, there's a lot of work going into precision application at the moment as well. So rather than relying on a single farmer mass spraying an entire field with the chemical, can we much more specifically target that application to where the weeds or diseases are? And then we also have a biologicals business as well. So this is looking at new alternative ways outside of more traditional chemistry application. In product safety, we are interested in safety, funnily enough. So primarily around mammalian toxicology, mammalian safety. There's a lot of analogy there to pharma companies that you might be more familiar with. So ensuring that accidental exposure to any of our chemicals via whatever route is safe. And that is both to humans as well as to any animals in the environment, and then more broadly within the environment as well. So we have to understand the complete life cycle, if you like, of our products. So what they break down into and where they end up, be that potentially in water, in the soil, or any combination thereof. Ensuring that essentially that remains safe and they are levels sufficiently low to not cause any safety concerns. So Synapse then. So what's our challenge? So the use case here, so there's an increased need to find relevant internal and external material to support the research and development phases of projects in Syngenta, helping scientists drive innovation. So as I mentioned, that's both new potential products to get to the market. Again, analogous to what you might hear around antibiotics, for example, there is resistance. We get exactly the same thing. So weeds and diseases become resistant to our older products. So we have to keep innovating and making new products and developing new products in order to help combat that. And then as well as continuing to keep our existing products on the market as well globally. And of course, those requirements vary from region to region across the world. The need to continue innovating unpacks a pair of particular challenges. So digital archaeology. So in essence, digging back through time. So we like to look backwards. We like to look retrospectively. And that involves looking across a whole range of different repositories and sources for material of relevance to our projects. And that's both, as I said, ongoing projects as well as new potential projects as well. So trying to develop new modes of action or new products with the same modes of action, understanding what potential issues or risks are there that we need to be aware of when developing new products. Our legacy stuff is in a whole variety of different places, in a whole variety of different formats, as you might imagine. So there are plenty of image-based PDFs that need OCR, other PDFs, PowerPoint files, Microsoft Word files, Excel files, JPEG, so image files, and then MOL files I mentioned there as well. So that's a structural file that I'll come back to a bit later. And inevitably, thousands of hours are spent by R&D scientists trying to find this relevant information. And that's, again, from early research and throughout development. So there is clearly an efficiency gain to be had here, where if we can speed up the time it takes our scientists to find the information, they can come to decisions quicker, we can understand risks quicker, and they can hopefully spend more time on other more value-added activities as a result. So what's the sorts of questions that we ask? So I mentioned we're looking back retrospectively. So what have we done before? This is important for idea and hypothesis generation. Prospectively, so have we seen this problem before? Have we seen this issue before? How did we solve it last time? Did we manage to solve it last time? What could we do this time that we didn't do last time? And projects sometimes fail, for example, just because of cost prohibition. And it might be that actually, if you look back at something another 10 years later, that cost balance ratio has changed and we can do something now that we couldn't have done previously. But there's a heavy reliance here on employee collective memory. So I talked to so-and-so and they said, oh, I sort of remember that we looked at this previously. But I had a quick look in my emails and I couldn't find any real reports or record of it. But maybe if you go and talk to this other person I think was also involved in the project, they might remember it or they might have some information. And often that can be a several person multi-hop jump until you finally find someone that's been in the company long enough to remember and have access to the information and remember where that information was. That, of course, assumes that you get to that point at all. Because people leave the company, people retire, some people aren't around as long. So finding that information can be much, much more difficult if you haven't got that historical memory or the employees with that collective memory. And then that, of course, leads on to the what about the things that we've already forgotten? There's plenty of stuff that I'm sure collectively we have entirely forgotten that we looked at previously at all. And then what else will we start to forget as we move on, as more people leave? So to give you a bit of a context and a bit of an idea about the scale of the problem that we're talking about here. So talking of history, a brief bit of Syngenta's history here. So what timescales are we talking about? So Syngenta was formed from a whole variety of different legacy companies. Syngenta itself formed in 2000, so not that old, relatively new. Google, for example, was formed in the late 90s, so it's comparable in that sense. And of course, many of the tech organizations that you're familiar with are in that sort of time frame as well. But each of these legacy companies that Syngenta was formed from had different systems, used different terminology, used different templates. And of course, there were various decisions at the time over what was not migrated, what was of high value to put that effort into. And of course, then we take a step back. When were those prior companies formed? Some of these companies you may still be familiar with, because things like Novartis are still around. But Cyber, Geigy, Sandoz, ICI, there are companies here back, as you can see, to 1758, 1884. That's somewhat predates any real notion of digital. And that makes it difficult because, as I said, that cost value balance might have said, we're not going to bother migrating it. We're not going to bother turning that digital at that point in time. Of course, that's all very good. Now we're looking back at it in hindsight and said, oh, it'd be really good if they had done that, but they haven't. So we have to find solutions around that now. The extra caveat then is that, of course, assumes that they were ever digitized at all. So you can see on the bottom left there, we also have lots and lots of files and pieces of paper and lab notebooks and slides and so on and so on and so forth that's actually still stored in cardboard boxes in a particular warehouse. So unfortunately, I'm not sure AI can even newer AI can solve that particular problem. But again, that cost value ratio changes. So where we need it, where we think it's necessary, we can try and go back and digitize some of those documents and files as well. So moving on to Synapse. So what is Synapse? So it's a new generation of enterprise search solution or tool that employs artificial intelligence technologies such as natural language processing, machine learning to ingest, understand, organize, and query digital content from multiple structured and unstructured sources that are located both internally and externally to Syngenta. Synapse itself has now been running for about a little over 7 years. Of course, technology changes in that time. So trying to ensure it keeps up to date and remains not only a new generation of enterprise search tool, but the next generation of enterprise search tool has been a interesting challenge, particularly in the last few years, as you might imagine. So what are its core platform capabilities? So first and foremost, intuitive search interface. If users can't interact with the system, then you've essentially lost them at the first hurdle. So you can search, filter, order, save, and share documents from within the system. It supports more traditional search terms and terminology, so things like Boolean operators and or not and near. You can adjust the orders of relevance. You can boost particular terms if things are particularly interesting to you that affects the order of the results and the rankings that you get back. And we support search of documents in multiple languages because we are a global company. So although English is our primary language, there are plenty of documents and reports that are written in more local languages around the world as well. We have visualizations and ontologies on particular query concepts. So it helps you to explore what kind of things are particular documents talking about, mentioning, and what are you seeing, and then that gives you ideas and suggestions to help further refine and filter your search results. Other functionalities such as exporting your search results, so you can export the results to potentially review them offline and then potentially import them back into the application if needed. And there's also automatic notification of new documents for existing queries. This is something that comes up quite regularly. Users want to know, is there something new about that thing that I'm interested in, about that thing that I'm looking at? Because the quicker we can spot that, the quicker we can react to that better. We also then do some iterations, so search of embedded documents. So where one file is embedded in another, we iteratively dig through that and pull those out. Same with compressed zip files and images as well. So then we also apply OCR to older documents as necessary. And then finally, we also link into some structured data sources. So this means as part of your text-based search, you can also see within the application, hang on, there might actually be some structured data available in this other database as well that might be relevant to the particular thing that you are looking at and are interested in. So I mentioned ontologies. So AI here helps us find and categorize concepts using knowledge graphs and tagging. So we tag the documents with these concepts. Some of the things here are fairly intuitive as to why we might be interested in them. So chemical substances, we are a chemical substance company. So we want to know where chemical substances are mentioned. I obviously showed you earlier all the different legacy companies that we're part of. And of course, each of those legacy companies use different identifiers for notionally the same thing. So we also want to harmonize and recognize those synonyms as well. Modes of actions are important to us. And ways of linking those as well, because just because a mode of action is important to us, we might know that certain chemicals have that mode of action or use that mode of action. And reports that mention those chemicals might not mention the mode of action explicitly, but that report might be of interest if you are more broadly searching for information about that mode of action, for example, so we can sort of propagate the search automatically in that way. There's some document-specific information that we recognize and extract, so authors, titles, types, and date information. And then product crop information as well, which is obviously of interest for fairly obviously for us, as we are an agricultural company. So recognizing what things are used where or can be used where is important, and that expands into commodities as well. So the thing you plant, the thing you grow, the thing you harvest, and then the thing you actually sell are not necessarily all the same thing. So the solution. So I won't go through this in explicit detail. but to give you an idea, so at the top left, there's a whole raft of different repositories that we pull information from, both externally, so journal abstracts, for example, and then some documents from some of our regulatory agency sites as well are of interest, both to see what they have done or how they've replied or how they responded to information that we've given them in the past, but also information that our competitors have given in the past. And then a whole raft of internal repository sources as well. So things like SharePoint, Document, and Viva Vault. These are our document reporting systems, and then extended into shared drives in some instances as well. I mentioned document formats earlier, so Word, PDF, images, PowerPoint, etc. There's some other file types you recognize as well. So we also pull in XML. So the Medline journal abstracts, for example, are XML. These are all run through our data flow orchestration engine, which calls a whole raft then of different other APIs in order, depending on what it's seeing. And these can include things like applying OCR, trying to extract tables, recognizing concepts, so applying the ontologies, for example, and storing that information. That then gives us a document in a standardized XML format for querying, which is stored in our database. So this is where we use MarkLogic. And then the search interface, the business users obviously then interact with the search interface, which then interacts through a series of APIs to query the database itself. And then, of course, we also have some other cases where other applications actually query our APIs directly to pull and do other things with those standardized XML documents as well. Now, as alluded to, we are a chemistry company, so chemistry interests us. So actually, it's not just a text search engine that we built here. We've also expanded it to enable us to search on and around chemistry and chemical structures. So there's two steps to this. So one is recognizing structures in documents. So sometimes we see structures embedded in documents. So that mol file example that I gave you earlier. Sometimes they're drawn in documents. That can be a bit harder to deal with. And equally, we can also map where we recognize the name of a chemical substance to its structure as well. That all then leads us to the second step, which is letting people search by chemical structures. So in the example here, you can see someone searched on a benzene ring at the top left. And it means we can actually return documents that have structures in them where they contain that substructure. So in red in each of those four chemical examples you've got there, you can see the benzene rings being highlighted. So those documents are being brought back because they have in them a structure that contains that benzene substructure. There's a lot of other intricacies around this because chemistry is complex. However, this is fundamentally useful because sometimes you're actually interested in what information you can see or is around a certain substructure of a chemical, for example. So does a certain substructure give a certain phenotypic result in some of the studies that we run, for example. So the user interface. So on the left here, you can see the basic Synapse user interface. Top left, you can see the drawing structure option. We've done an example search here, Boolean search between a chemical substance and using a particular source, so regulations.gov. Left-hand side, you have additional search facets and filters, as you might expect. So we can filter on resource types, document types, and species, as well as by date. On the right-hand side, you get some extra information correlating to the search that you ran. So you can see that we've also propagated that as oxystrobin search to a number of different legacy synonyms that we know azoxystrobin is associated with. Bottom right, you can see the structure of azoxystrobin. So we try, as I alluded to, pulling information from some other structured databases. We try and give additional information here that might be relevant. And in the center, you've then got the listed search results. Each of those can be expanded to also give you text snippets around why has this document come back. And then we also let the user navigate to each of those documents, both within the application and the extent to the original sources and source files as well. On the right is something else that we've been playing with, which is essentially, okay, of that set of document search results, so there were 646 in the left there, how can we help the user navigate between those? Historically, a lot of people are used to using things like Google search, where you hope that the result that you want is on the first page, possibly the second page. Most of us probably don't navigate much beyond the third page in most instances. But that's when you're looking for a particular bit of information or a kind of fact in some sense. in a lot of what we're doing here, we're actually interested in the complete set of information about a compound, about a mode of action, about a study. So actually, how do we help users essentially further filter down, further navigate, further remove sets of documents that are irrelevant to what they're looking at, without them having to click through and navigate through each and every single one of those search results pages? So what does Synapse enabled? So it provides scientists and specialists with the ability to find a range of relevant information in seconds. Individual searches are much faster here than in some of the typical legacy systems. And of course, this allows a user to search across multiple systems in a single place and receive all those results in a single place as well. So it's delivering real benefits for a number of R&D staff, if just for the speed piece, but also letting them find information that otherwise they might just not have known existed. And this means they can spend more time on innovation and using the information that Synapse gives them, rather than spending all their time trying to find that information, assuming they even knew it existed in the first place. So some of the challenges, so there's a lot of variation in the document types, formats, locations, ages that we have, as well as versions. So a lot of documents have multiple different versions. And depending on the search you're doing, sometimes the differences between those versions matter. Often it doesn't. Coverage is always a problem. So have we included enough? If there's a document someone knows exists somewhere but they can't find, that can add an additional barrier to having them uptake and use the system. Timeliness of new files is a problem, because in general, as I alluded to with the notifications bit earlier, we want to know as soon as possible that something new has appeared. But that's weighed up against the scope of the number of different people that might have access to the application. So I want to know that a new document has appeared around my particular project, but I might want to know that and have a chance to review that and have a chance to look at that before everyone else also has that same notification. Too many results is an interesting bit that we've got back. So I ran a search and I got 10,000 results back. Now what? You can argue that's better than previously, where they didn't have any results or they were struggling to find 3 results. But equally, you can recognize that 10,000 results is too many to go through one at a time. So as I showed you on the previous slide, how do we help them further refine that, further filter that down? Access management, so finding things in places where they shouldn't be. That's kind of primarily a knowledge management problem, but it's one that's going to exist in legacy systems and legacy information regardless. So it's something we have to work around and acknowledge and try and navigate. And then that kind of links into the single point and source of truth as well. So a single document might be in multiple locations. Which of those is the correct one? Which of those are old versions? Which of those are new versions that just haven't been formally recognized yet? And then we're also getting requests for data from the documents as well as the documents themselves. It's like, great, so you've taken me to the document, but I want a particular data table out of that document, for example. Or I want some particular data in that document or some data across multiple documents. So how do we try and help enable that? And then with the chemical structures as well. So drawn structures, we require OCSR, so optical chemical structure recognition, to try and pull out. And that technology is better or worse, like OCR itself, depending on the quality of the image that you're looking at. But the opportunities, so this gives us a rich source of standardized document text, which enables data analytics, knowledge graphs, natural language processing, data extraction. So all of these sort of core technologies it enables from a few years ago. Relationship extraction, correlation, causation, moving towards, and then of course the newer technologies such as LLMs. Chatbots sat on top of it, for example, so enable people to much more interactively query the data and get an answer back rather than just being told, here's the document that may contain an answer. And I'm assuming this forms a part of the future of agentic AI as well. So forms one piece of the information that goes into that puzzle. And then the other opportunity, so to learn from our mistakes. So what have we not quite got right in the past? And what should we change to make this easier and better for us in the future? So some of the next steps. So always trying to add more information, more documents, more corpora and repositories, especially globally. So talking to some of our various colleagues in the various different regions, what additional sources have they got? What's useful to them? What could they do with having included, both internally within Syngenta and externally as well? So additional SharePoints, additional file sources, file shares, and additional publications and regulatory data as well. Continuing the rollout again to the regions. So have we got the information that you need? Is this useful? What additional do you need to make it really useful, to make it really obvious, to get that immediate benefit? And then this forms a part of general digital upskilling as well. So just making sure that everyone is engaged, understands the tools that are available, and then utilizes those tools that are available as well as possible. Adding some additional visualizations. So I showed you that a few slides back. And then embracing the opportunities as well, in particular around the LLMs and generative AI technology. So to finish with a few acknowledgements, so thanks to some of the internal project team members, so Pete, Alison, and Mike, our user community. It is, of course, this has been an agile project. Feedback is key, and getting engagement from the users as quickly and as often as possible is very important. And then reacting to and adjusting to that engagement as quickly as possible is important as well, to keep that engagement and keep the momentum going. And then thanks to the external teams as well. So the technical teams have been involved. So a number of people from DataVid, and then obviously Progress and MarkLogic here, both for this seminar. And as MarkLogic has been a core part of our solution so far. So thank you for that. And I'll finish there.
Thank you, Geraint. And it was such a rich and insightful presentation. And at DataVid, it's been a real privilege for us to partner with Syngenta on this journey and see how, Synapse has moved from a concept to a system that, is helping, with scientific discovery. It's truly inspiring for us. And I think Synapse brings, to life the challenges and opportunities that so many organizations are facing when they want to unlock the hidden value in their historical R&D knowledge. And the way, Synapse is using knowledge graphs and chemical structure search and semantic AI search on the scientific data and legacy, historical documents and data, it really, can be very transformative, for the R&D teams. I have few questions to ask you, from your perspective, what has been the, the most surprising or valuable scientific insight the Synapse system has helped surface so far?
Yeah, thanks. It's interesting, isn't it? I mean, some of this is very hard to quantify. It's kind of like if Synapse lets a user find something that they otherwise didn't know about and may have never found, and if that becomes a core part of a new product strategy or a decision we take, you'll never really know what the actual monetary value of that ends up being. But on a more local level, right? I said it often has helped us find documents that we didn't know about or otherwise thought were lost. As I alluded to earlier, those sort of multi-hop links. So A might lead to B, might lead to C, might lead to D. And one person being in the place where they know all of those links and have the documents and data that shows them all of those links is really difficult unless you're one of those that has been in the company for several decades. And this helps newer employees find that information and find those threads and find those bits of variation to start digging and start thinking about it and start coming to those hypotheses and conclusions. So we use this information, for example, as one of our, to help with one of our previous projects where we were trying to look at all the information around a particular mode of action. We pulled in all the documents and all the data that Synapse had around this particular mode of action. And it still involved a fair degree of user effort to go through some of this. But I think from what I remember, Synapse brought back some particular documents that highlighted there might be a particular risk here, or we saw this particular risk with this compound 10, 15 years ago. It was only a potential risk. It wasn't really certain, but it was very important to highlight that for the new project so they're aware of that and can build that into the roadmap rather than end up with an unexpected surprise later on. And the other interesting thing, right, is that lost documents bit. So this has also helped us find documents in some interesting places. So there have been documents and files, for example, where we've found, or the only place we found that document was in a mind map sat on a shared drive somewhere of a use of someone that has since left the company. And without this kind of technology, if we're being honest, I don't think we'd have tracked that down otherwise.
Yeah, that's certainly helpful, right? Like all that knowledge that you mentioned, which was in, people's mind map, and they're leaving the organization, retiring, and then new new employees coming in, how can they access that previous research and previous knowledge that was done? It's all,
Yeah,
it's
something that's
very
intuitive to
important.
one person is not necessarily intuitive to the next person. Yeah.
Yeah. So, looking ahead 2, 3 years, what opportunities do you see extending this approach, either in new domains within Syngenta or, broadly across the industry?
Yeah, so obviously I alluded to in the presentation, sort of expanding it to regions and other areas globally. Each of those brings opportunities and challenges because each of those might have slightly different sources that they're interested in, or particular sources that they use that aren't used elsewhere. And of course, each group probably has its own internal file shares and so on and so forth, where they've been storing stuff a bit more locally. Some of that might be solved with a sort of perfect knowledge management solution, but in practice, with all the legacy that we've got, trying to bring all that into a single place is the only viable solution, probably in the immediate term. But I think the big opportunities here, right, are around some of the newer LLM technology and generative AI technology. Synapse here as it is gives us a lovely baseline that says, okay, we've done all the integrations, we've pulled all the documents in, we're getting all the data in a stricter sense in a single place, in a consistent place. That lets us build much more interesting things on top of it. So Synapse, yes, lets you run a search index over it, lets you do a search interface over it, and lets users find documents. Because the real interest and real buzz now is all around, well, can I just ask questions and get answers back? And I think I've seen some examples where that seems and feels entirely realistic and plausible now with the newer technology of the last few years. But like anything, even for the AI to give you an answer, it still has to have the answer or have seen the answer somewhere already. So if it's in a document somewhere that no one knows about, that no one's ever managed to find, even the generative AI is not going to give you that answer. So this provides a lovely baseline to help us build and investigate some of those newer use cases and technologies on top of. So I'm quite excited to see what that'll enable us to do and over the next few years.
Yeah, so this is a perfect example where you already have this knowledge base created, and you can use this to get sort of the verifiable AI, like verifiable information using AI. Because otherwise, AI can produce, how do you verify where this information
Yeah.
came from? So with Synapse, you already have the infrastructure, you already have the base, and with LLMs, you can then try to, users can query and get verified information. So, as you said, AI is only as useful as the underlying data that you're feeding to the AI. So what advice would you like to give to other organizations who are just starting to think about unlocking their historical knowledge? Where should they begin? What are the things they should look at?
Interesting question, right? So there's some baseline stuff, right? So as we just alluded to, working out or having some idea where the answer is not straightforward, it's not easy. But trying to sort of look towards where are the possible places it could be, and trying to start slowly bringing and incorporating those into to any particular solution. Some of that, in hindsight, if you like, can be solved, as I alluded to, with great perfect knowledge management solutions. So ensuring that every user stores and saves their documents in the right format, in the right place, every single time, everything's perfectly versioned, everything has provenance and history, would be lovely and would solve a lot of these problems. But like anything, time, effort, value comes into these conversations, and not everything needs that. Well, not everything necessarily needs that degree of rigor, but also in practice, not everything will ever have that degree of rigor, because the cost just doesn't the cost value just doesn't seem to necessarily be there. And equally, people will be people. People will be people, and even with the best will in the world, even if you solve that now, you're not going to magically solve that for everything in your history as well. But hindsight's great, so trying to do better, trying to improve things where you are now from what they were previously helps. And then at the same time, working to incorporate the legacy stuff in a way that you can do so as well. So building that baseline, I think, is the important first step. Technology, of course, the AI technology is improving a lot over the last few years. There's lots of interesting things it can do and enables, if it can be directed to the right data at the right point.
Yeah, thank you very much. On behalf of everyone, I'd like to thank you once again for, taking the time to share your story and share the knowledge around Synapse and all the learnings. And I know it will resonate very widely with, across life science community who are also thinking about how to use their, legacy documents and their knowledge assets more effectively. So thank you once again.
Yeah, thank you very much. It's been an ongoing journey. We're not there yet, and there's plenty more to do, and plenty more opportunity and excitement to come.
Thanks very much, Balvinder and Geraint. That was a fascinating presentation. A really interesting use of MarkLogic and David, kind of that combination with your expertise in the chemistry field there. Yeah, really interesting use case, and I think I echo Balvinder's sentiments when I say that you created a really good platform from which to develop and iterate kind of these next gen AI, but also other tools that you can build on top of this system. So yeah, congratulations on all your hard work, and I look forward to seeing what it looks like in a year's time or maybe 2 years' time. So yeah, thank you very much. If we didn't get around to answering your questions today, then we'll reach out to you and get answers to you from either ourselves or Vinder or from Geraint. Thank you very much for joining us. And yeah, once again, thank you very much to both our speakers.